So hello everyone, after all this organization. So my name is Dana, and I'm a software developer from AppsFlyer, and here with me is Ellie.
Hi, my name is Eli. I am leading the cloud platform team in AppsFlyer.
So we are here today to share with you from our experience of building a new customer-facing feature. And what was unique about this project is that we work together, platform and dev, on the same code base and for the same purpose on building not an infrastructure, but a customer-facing product. So let's start. A little bit about AppsFlyer. So AppsFlyer is the world's leading mobile attribution and marketing analytics platform. We help app marketeers around the world to make better decisions and basically get better insights on how their campaigns performs. So we process around 90 billion events per day. Sometimes it's less, sometimes it's more, depends on the traffic, of course. And our SDK is integrated in around 95% of all the devices around the world. So basically, most of you, without knowing, have our SDK in your mobile phones. And all this operation is done with something like small amount of 10,000 servers, which is a lot. So one of the products that leads some of the traffic to our system is called OneLink, and this is the product that I'm working in the team. And a small overview, just so you have some context for this talk, because the feature we developed was for this product. So OneLink is an AppsFlyer link, and it gives advertisers the ability to perform device detection, to make redirections, and basically to customize the journey from the app, from the web to the app of their users. And till this solution that we are about to present, our customers used our own domain for publishing those links all over the web, and they wanted the ability to use their own domain, their own brand. This is what we call branded links. So why we need branded links when clicking on an ad and opening an app? So the first reason and the most obvious one is strong branding. Okay, if a user will see this link with the AppsFlyer domain, and will see this link with the customer domain, probably much more clicks will be on the second one because it's the brand. The users knows this brand, and it's not a third-party domain for the customer and for the users. Another reason is for email campaigns. So email campaign is a popular advertising medium. Probably all of you are getting a lot of emails, advertising emails. And one of the basic rules of email engines today is to match between the sender's domain, who sends the email, and the links inside the email. So if it's a branded domain, it's good, and it's getting to your inbox. And if it's not branded domain, it will go to your spam. Sorry, not this spam, but this spam. So there are much more reasons, but these two are just for the example. And on top of that, on top of the branded links, we need to have HTTPS. Why we need this HTTPS?
I have this nice robot to someone who will help me to answer the following question. Do you know who invented the HTTPS?
Google.
No.
Netscape.
Right. As you can see, the lock is pretty old. The year is 1994. The internet is getting popular. The World Wide Web. It's so slow back then that people intend to call it the World Wide Wait. Netscape is dominating the browser markets. Is anyone using Netscape today? And they decide to invent HTTPS. They invent HTTPS, the encryption, in order to have trust and security between the website owners and the users. The traffic is encrypted, less chance of data leakage, and man-in-the-middle attacks. Privacy is kind of important, and HTTPS is good for privacy. And of course, search engines are giving a higher rank to websites that are using encryption HTTPS. If the previous reasons are important for the webs, for deep link, it's completely a must. Do you remember the following slide that Dana presented? So once the user is clicking on the deep link, if the deep link is not using HTTPS, it will be just blocked by the operating system of a mobile. So what do we need in order to have HTTPS? We will need SSL certificate. And in order to get an SSL certificate, we need to enroll with CA authority like GoDaddy that will perform validation that you are the legal owner of the domain. Then you will get the certificate, deploy it on your environment, monitor, renew it. Maybe not a huge operation if you need to do it once in a few years, and most of the tasks here can be automated, but imagine that you need to do it for thousands of customers, when each customer can have multiple certificates. This clearly doesn't scale. You need to run operation, you need to have your customer support, talk to your customer, remind them to renew the certificate, and some customers are not technical guys, they need to talk to their IT, their security, get the certificate, a lot of manual tasks and bureaucracy. So we started to look for a solution that will help us to reduce the operation. AWS has a managed certificate solution, ACM. It's a very good solution. It allows you to get a free certificate and deploy them on AWS environment. And it has a good API. You can use Terraform. It's a very nice solution, but there is one limit there. You can deploy up to 25 certificates per load balancer. And this is something that not scaled enough for us. Have anyone here heard about Letsencrypt? Raise your hands.
Cool. So actually, Letsencrypt is the most popular authority today. And I don't know if you heard, but 60% of the certificates issuing today are done by Letsencrypt. So most of the certificates around the internet are owned by Letsencrypt. Last June, they reached an amazing record of generating around 2 million certificates in one day. Amazing. So this clearly does scale. And we felt that Letsencrypt is the right solution for us. So we started some POCs. And we came up with a solution that we can start with. It's an open source package called Lua REST autossl, and it's what we needed. So we are ready to start the development, right? And the first step, as you probably know, when you approach to a new project, is to get a proper name. So we are happy to introduce the Glassgate.
Glassgate is our solution to manage the customer certificates. Let's talk a little bit about the architecture. So this is existing non-branded click system. It's a pretty standard architecture for running your system in AWS. We use Route 53 for public domain. We use ELB load balancing that is balancing the traffic between our web servers that are using Aerospike, S3, Redis, and Kafka for the event processing. A question that always comes up with the slide, why do we have many load balancer? Load balancer is a managed service by AWS. It's fully scalable, fully managed. So why do you need more than one? And the reason is that we have so much traffic that even the biggest AWS ELB instance cannot handle the traffic. So the solution for it is to shard the traffic between different load balancer and perform the balancing between the load balancer on the Route 53. Each good architecture slide should have many logos, and we do have many open source logos. We use Nginx, we use Redis, Letsencrypt, OpenResty, and Lua autossl module. Let's start with the implementation. First of all, as I mentioned, we have a lot of logos and a lot of stuff to maintain. So we decided to look for a containerized solution. And luckily, we found one on a Docker app, an official OpenResty container, which is based on Alpine. So the only thing that we had to add is the autossl module, and it's pretty easy to add since the Lua ROC is already installed. And we had to add additional modules for the monitoring and the caching. So we have the container. Let's deploy the container on the front line. The container should do the SSL termination. It will use the Letsencrypt in order to provision the certificate. And then the users, in order to use our system, need to use his own domain. So basically, instead of using our domain in Route 53, the user will be able to configure his own domain that is owned by him to point to our solution. In order to make the solution more effective, let's move the traffic instead of the external ELB, let's forward it to internal ELB. Redundancy, we want to run more than one node. We expect a lot of traffic and want to have redundancy. So we'll need to deploy load balancer. NLB looked like the right solution for us since the SSL termination is being performed on our GlassGate nodes. And we had to get the user real IP in order to perform the geolocation in our click system. Each GlassGate node has its own certificate store. So once we have a request for a specific domain, if we don't have the certificate, we go to Letsencrypt that provisions the certificate, and the certificate is being deployed in our system. But the main thing that if the same domain request is getting to a different node, we need to do it again and go to Letsencrypt. And we will likely hit the limits of Letsencrypt because we're asking for the same certificate more than once. So let's deploy central certificate storage, which will be based on Redis. Of course, the Redis will be a redundant solution. Okay, now let's take a look at the whole system. The system was designed in a way that each component could be scaled horizontally. We can add many GlassGate nodes, we can run the solution on spots, we can add NLBs if needed, and basically in order to make it more efficient, we added a caching layer of the certificates. The Redis is keeping the certificate. So once each node is coming up, we prefetch all customer certificates that already exist from the Redis into the memory. So basically, the Redis is only used for the certificate provision and renewal. One particular thing about the solution is the DNS. Once we deploy the solution for our customer, we basically start to use the customer DNS, and we lose control over the DNS. And it's not very easy to perform changes for thousands of customers. So the solution was to use the intermediate DNS that is owned by AppsFlyer. Let's follow the scenario. We have customer, mybooks.com, that is configured his own DNS system to use our GlassGate solution. So instead of forwarding his DNS to CNAME, that is our NLB, we ask the customer to use his domain and in our intermediate domain, let's say brandedlink.com, that is running in Route 53 and owned by AppsFlyer. In order not to have the need to configure a record for each customer that we add to the system, we added a wildcard domain, basically that is forwarding to our NLB solution. This way, we gain the control of the DNS in our hands. We can change, we can move between the solution, between the clouds, between the region if needed. And if we need to do something for a particular customer, we can add his record into the DNS and move them to different solution. So can we go to have some beer?
Not yet. Let's talk about visibility. We have a high available system and scalable one, and it's a great solution, the ultimate one we could have found. But we need to understand what's going on now. So the next step is to perform some load tests, and in order to understand if we can handle the load or not, we need to have a clear visibility on what is going on. So Nginx provides some stats which are good, but as we said, we add some Lua logic inside, and we have our own OneLink internal click systems that we want to understand if it's getting affected or not. So we added Lua stats to have the full picture and full visibility on the system. So this is an example for the dashboard we created. It has the Lua stats, the Nginx stats, we have our internal stats, and by that, in one dashboard, we have a full visibility on all the system. On top of that, we have, of course, logs that are coming from the system. So we added the Kibana dashboard to understand some of the logics and the logs that are coming. And with the Kibana dashboard and this Grafana dashboard, we have a full visibility. We run the load tests. We can understand what is the load that we can handle, how we can autoscale our system. And now we have the full picture. So now we are almost good. We have one more scenario to cover, and this is not valid requests that are coming to our system. So probably, as you know, servers are getting traffic from bots, from hackers, from customers that are not authorized, because this feature is not for all the customers, of course. And we don't want to go to Letsencrypt and issue a certificate for every non-valid request that we are getting. Also, Letsencrypt does their own validation on the domains. So if it's a non-valid request from Letsencrypt side, we can get blocked because we are the source for this request. So obviously, we don't want to get blocked, and we don't want to process unauthorized requests. So we added a verification for the domains, and if the verification fails, we don't send traffic to Letsencrypt, and by that we are protecting not just by getting blocked by Letsencrypt, but also we are protecting our internal click system from getting redundant traffic. So this is a very important key, and we also added caching layer on top of it. So if we're getting the same non-valid requests, we are caching them and not trying to understand if it's valid or not again and again and again. We just reduce the loads from our internal components like the Redis and our own Glassgate nodes, and we cache them and we reduce the load. So to recap and to understand what we and you can learn from this project we did and from this component. So the first thing is domain verification. You want to protect your system, you want to be high available, you don't want to get blocked, and you don't want to process spam or unauthorized traffic. You need to have cache. Cache will protect you on top of the verification, and we will want to cache and reduce the load from our verification process and not check again and again the same requests. We have a central certificate storage. We have many nodes, and we want to be able to auto-scale it, scale up or scale down. So we need a central certificate storage so the nodes can reach to it and understand if the certificate is already existed or not, if we need to go to Letsencrypt and issue a new one. And pre-warming, again, to reduce the load from our Redis and components. We want to use the Redis and to reach Redis only when we need to issue a new certificate or renewal an existing one. So for a normal flow of existing certificate, we do pre-warming, so every node has all the certificates inside his memory and doesn't need to go to Redis for each request. And finally, humans do mistake, as you probably know, and developers do a lot of mistakes. So we want to protect the system, and we don't want to get to Letsencrypt limits. We don't want to harm our production. So it's really important to use Letsencrypt staging environment they provide. In general, it's not a good practice to use staging environment in front of a production environment. So while testing and while developing, it's really important to use the staging environment. And finally, I think that the main point here is when working on this kind of project that has a lot of infrastructure, but is also a customer-facing feature, it's important to create a holistic team like we did of platform and developers and work together without any differences. This work really good for us, and we are really recommending you to use the same method. So thank you, Ellie.
Thank you, Dana.